Well, hey everybody. My name is Elijah Meeks. I work at Netflix. I'm also the author of D3JS in Action, which is a book by Manning, or published by Manning, I guess by me, about how to use D3JS in the data visualization library. I just finished writing the second edition of it. It's available in early access, and it'll be published soon as a paper copy. And I work at Netflix, and at Netflix what I do is I build internal data visualization applications for a variety of teams at Netflix. I make things for the science and algorithms team so we can see how the Netflix algorithm is performing. I make things for the non-member team to see how people are joining Netflix and why and where they're joining. And various other teams at Netflix. And what I wanted to talk about today was more rules for Data Vis. And particularly I wanted to address what I think is a valuable metaphor in approaching Data Vis, which is to think about how you might lint your data visualization. So along with writing D3JS in Action, I've been writing a lot about the state of Data Vis lately on Medium. So I've been talking about the professionalization of Data Vis and whether or not it's a profession or a skill. And we've seen a lot of traction, myself and a few other writers who are dealing with this topic. And so I thought, now that I'm a thought leader, I should go out and thought lead. So I went out on Twitter and tried to help people with constructive criticism of the charts they might have posted on Twitter. And I found that my very constructive criticism wasn't really useful to folks. And in fact, what I heard most of the time was when I would point out that a particular chart was bad. For instance, like the climate chart up on the right there, that my critique was taken to mean the chart wasn't pretty. And we hear pretty a lot. We hear, people sort of address in passing aesthetic values around data visualization. My talk is not about aesthetics of data viz, it's about usefulness. And to my mind, it was more of a language question. Now, obviously, I noticed there were no chuckles in the audience, so maybe you guys thought that I actually was being constructive in these tweets, but I wasn't. And so I thought, well, what's a constructive approach that'll help folks to better deal with the construction of data visualization? And in doing so, I ran into the same problem I'm sure a lot of folks in this audience are already thinking, which is we've got enough rules about data viz. There's entire libraries of data visualization manuals. And they're useful. The various authors like Stephen Few or Stephanie Evergreen are very useful, but they're oftentimes holistic in what they describe and how you should approach data viz and deal with data visualization. So first I wanted to touch a little bit on how these authors are embedded in certain views of data visualization. And primarily it relies on this oversimplification of what the data visualization process is. And I want to pose to you this idea that data visualization has these steps. And these steps are obviously fuzzy. There's a lot of analysis that goes on in the requirements gathering phase. There's a lot of creation that goes on in all of these phases. But really, when you look at the literature and you look at the tools that are being built, they're focused on these ideas around data visualization. So fundamentally, when I talk about analysis, I'm thinking about data visualization as a data transformation form. So in this regard, I'm thinking about scientists and analysts who are deeply embedded in the data set that they're trying to understand. And some of you might think that that's the only way that data visualization happens. It's not what happens, it does happen at Netflix. It's not what happens at Netflix that I'm involved with. What I do is I build large-scale applications that require me to interact with domain experts. I'm not an expert on the various data sources that I deal with. Like I said, I couldn't be an expert on both non-member and algorithm performance, much less that and how members are acting or how Netflix marketing is working. But for folks who are focused on analysis and are using data visualization as sort of a skill while they analyze data sets, it's about how many different ways can I take the data in my data set that I'm an expert in and present it on screen as a graphical, as a set of graphical elements. And for them, this data transformation mode is most useful. And that data transformation mode really comes out of a set of literature that's typified by Grammar of Graphics, Leland Wilkinson's work. And Grammar of Graphics describes this sort of stepwise data transformation pattern, how to take numerical data and turn it into graphical elements that accurately describe numerical data like length or size. And it underlies the major libraries that we think of for sort of low-level data visualization like ggplot and D3, which both come out of this Grammar of Graphics heritage. There's another perspective that focuses on data visualization as a resource allocation problem. That terminology comes from Tamara Munzner's book, Visualization, Analysis, and Design, which is the best text for this perspective. And it really relies on this approach that we think of when we think of user-centered design. So data visualization is not how do I show the most data. It's rather how do I show data effectively given a certain kind of audience that's in a certain kind of mode. And so that focuses on distinctions between exploratory versus explanatory graphics and how you might take certain chart elements and combine them with certain user interface elements to produce an application that's the most useful for your audience. And what comes out of that are the charting libraries. They're really built on top of those low-level libraries, so high charts or Plotly is sort of in a place, I think, that's between notebooks and these kind of charting libraries. But victory charts, high charts, read charts, all of these various charting libraries. And what they try to do is not only provide you with methods to transform data into graphical attributes, but also methods to allow you to navigate that data or present that data more effectively. So I'm going to jump to the end of that simple process and talk about the evaluation perspective on data visualization. And there's a lot of literature about evaluating final pieces of data visualization. And Tufte's in this category, but I think the best work is Alberto Cairo's The Functional Art. And when you read this literature, what you see is an analysis of a final product, right? Some piece that shows up in a newspaper or online somewhere. And that analysis typically focuses on these rules for how you might process that final product. And those rules, roughly speaking, fall into two categories. One of them is cognition rules, visual cognition. So when we talk about Gestalt principles, I wrote a series on Gestalt principles as they apply to data visualization, which for those of you who aren't into German psychology, just refers to how different shapes on screen might interact, whether wittingly or unwittingly, with each other to show other kinds of shapes. And I think the best example of that is what's known as a difference chart. So if you look on the bottom left, and in this GIF that comes from one of my pieces on this, you can see a difference chart. And a difference chart is basically two line charts where you style the difference between them differently depending on whether or not one line is above the other. And so what you really do is you use these fundamental rules for how we visualize things to emphasize that difference so that the line charts still exist, but they exist as these undrawn tops and bottoms of that total shape there at the bottom left. And I found it one of the most effective of these sort of non-stereotypical charting methods or non-basic charting methods that you see deployed. And it relies very much on that cognition perspective. There's another cognition perspective, and it's this sort of rhetorical cognition, how people process the story that a data is telling. And you'll hear about that or you'll read about that when people are analyzing work, and they'll say, well, the color red means one thing for a certain culture, it means another thing for another culture. Or by showing this chart on screen and having this really high point here, even though that high point isn't very anomalous, the person reading it will assume that it's an important thing, whether or not you actually intended for them to think it was important. And there's a lot of rules that you can gather out of these that are useful for improving your data visualization. I think we're doing a good job as a community of integrating. But like I said, they're very holistic, and it's hard sometimes to imagine somebody internalizing all of them to produce a chart like that climate change chart that the response when I tweeted how I thought it was a bad chart was that, well, it's an okay chart because it's made by scientists and it's meant to communicate with scientists. And scientists aren't expecting all of this stuff. They don't expect what's going on in journalism. So I want to try to focus in on a different aspect of that process, the actual active creation process when you're writing data visualization code. And whether or not you're actually writing it in some kind of IDE or you're using some kind of graphical user interface to build it. And when it comes to the actual creation of individual elements of data visualization, we don't have much as far as rules. What we have is examples. We have lots and lots of examples of how to make different kinds of data visualization. I come out of the D3 community, and in the D3 community, we do things by example all the time. And so you see D3JS practitioners have a lot of blocks like this. I mean, blocks is a website for displaying small examples from just.github and showing these individual data visualization examples that are importantly divorced from data. So unlike analysis and unlike the requirements gathering phase or the evaluation phase, this has very little to do with data. Oftentimes these examples use randomly generated data, or they use one of these sort of typical data sets like the Les Miserables network data set or the Flare data set for hierarchical data. And they don't really talk about what's good, and what you see coming out of those examples is a lot of things where somebody says, well, don't mind that it's ugly or unreadable or whatever. It's a tree map, and isn't it interesting that I've done this thing with a tree map? And I say that very self-consciously because I'm one of those people. But when you look at that creation phase, there's actually two interesting ways we could think about how rules apply to just that creation moment when you're writing data visualization. And they come from these two metaphors in programming that are linting and unit testing. And we can think about linting as being something that is unrelated to data. So when I'm just writing code to create some kind of chart, there are rules for what you should do when you're building that, even before data is applied. Now, when data is applied, we can use this unit testing metaphor. And then we can use methods to examine whether or not I'm showing on screen a lot of cluttered graphical elements that are hard for people to read. But I want to really drill down and focus in on this linting idea. And so what do I mean by linting? Maybe some of you aren't familiar with linting. Linting is basically what's known as static analysis. It's really just analyzing your code as you're writing your code to make sure that certain rules that you or your organization has declared to be rules to follow are being followed. Now, oftentimes what that means is it's about just formatting. You should have tabs, or you should have spaces, or you should use semicolons, or you shouldn't. But there are linting rules that actually have to do with the structure of the code that you're creating. There are rules that say you can't use a for loop this way, or that you can't use some kind of prototyping method. And so we could imagine these kind of rules for data visualization, and maybe as we get into developing rules like that, we could actually build linters for data visualization code, particularly to the libraries that we're building. And by divorcing it from the actual data, we get away from all of these lessons and biases that people have who are deeply embedded in the particular domain and the particular data set that they're trying to visualize. So there are some general rules that if you've read any of this literature that you know about. Stephanie Evergreen champions the idea that, first of all of your charts should have a title. So that could be a simple rule that in your code it says it gives you a warning or an error. And this is another important thing about linting. These aren't rules that you're never allowed to break, but rather they might be rules that warn you when you are breaking them. But you should have titles, and you could imagine in a unit testing metaphor how those titles could actually be required to be long titles. So there's this concept of sentencifying things, so that a chart shouldn't just have a single word as its title. It should have a sentence that describes the chart. There are other more complicated rules like maximum encoding. You know, I'm familiar with, and I'm sure a lot of you are, the scatter plots that people have made where they try to encode in the scatter plot size, and maybe they even use the border width of the circle, and then they use a lot of colors, and at the end of the day you've got a scatter plot with so many different channels communicating so much different data that you're really not giving your reader a chance. And once again, these are things that you could be warned about even before you put data into the system. There's also more straightforward rules that we're all familiar with, like you should have axes and you should have legends, that again, we can test without applying data at all. Other general principles, ones that you're probably familiar with if you follow any of the sort of slap fighting that goes on with Data Vis Twitter, like nobody should ever use a pie chart, or maybe if you use a pie chart, it should only have so many pieces. And really, that same rule could apply to histograms, or maybe you should just never use radial charts. Here's a radial tree map I made that would definitely error out if you had that turned on. And that simple rules like value ordering, you shouldn't just have things that are ordered randomly in the order that they came out of the array. There should be some kind of mindful ordering to them, because people take ordering seriously when they read data visualization. There's more specific rules for different categories of data that you're dealing with. So when it comes to XY data, you should have in place collision handling, because if you're plotting things in XY space and those things are on top of each other, then your reader can't read them. And that's not something that you even need to put data into the application for. It's something that you can tell because you can say, hey, you have no collision handling. And then what kind of collision handling could depend on unit tests, things like that. Fitts law handling, if you create an element that's interactive, well, that element should be large enough to be interacted with. And that's all Fitts law is about, is that an element has to be of a certain size for people to be able to interact with it. You should encode uncertainty and error. There should be handling for that. Not necessarily that you have errors and uncertainty, but that your system should be aware that that happens. Mind the gap, a very specific rule. Most data visualization libraries now can handle gaps in data. So for line charts, it used to be you'd always have to worry about there being gaps in the data and then the line being interpolated between those gaps, which would actually give the wrong signal to your reader. When D3, V4, and other data visualization libraries now have functionality in place to handle undefined data points. So here's an example from the real world. This is a New York Times piece about water usage in California. You notice that they'd get a warning about using axes, but you could see how they would disregard that warning, because you don't need latitude and longitude lines. People can recognize the landmarks in California. It's got labeling, it's got annotations, it's got a legend. It's not using a color range for that legend, it's using discrete colors. So it's great, except that all of these points are overlapping on top of each other. So when you look at Los Angeles, or when you look up in Sacramento or San Francisco, as a reader of this data visualization, you can't really tell what's going on other than a lot, and it varies. So if collision handling was in place, then they'd be forced to deal with that. They'd say, well, maybe we should bin this. Maybe we should somehow aggregate these data points. Again, as you get into more specific complex chart types, there are rules that you could apply. This is a bar chart made out of tree maps, and when I saw it, I was really upset. And I was really upset because this is the kind of thing that I make. And I was upset that somebody else had made this. But most people, when they saw it on Twitter, were upset because how can you expect a reader to actually measure the difference in those two bars on the left between imports and exports when the tree map, because it's just a naive tree map, has ordered things in a way that it makes it impossible to measure the difference between the blue and the orange regions. So that's a very specific rule. You could imagine genericizing that rule to not using hierarchical layouts, to do what is fundamentally a small multiples view. And you could imagine how this would cause you to then be more thoughtful about how you were presenting, for instance, small multiples of hierarchical visualization. In my book, in the second edition, I spent an entire chapter on hierarchical data viz. And I spent a bit more time talking about each of these different kinds of hierarchical data visualization methods, like dendrograms, tree maps, and circle packs, and coming up with specific rules for when one of them is suitable and when one of them isn't. And that's because most people just think that, I feel like making a tree map today, or I feel like making a circle pack today. And really, the methods of expression of those layouts are more suited to certain types of data. When it comes to network data, and I've worked with network data a lot in my time, and lately at Netflix, you've got this problem when it comes to thinking of linting rules for network data. And that's because network data, more than other kinds of data, is really dependent on the structure of the network. So when is it suitable to use a force-directed algorithm to present network data? Well, that depends on what kind of network you're dealing with and what the demography of that network is, whether or not it has a lot of links and whether or not those links are very cluttered. And so there are, in the blue here, some of what I would think of as possible unit testing rules for network data, where you might display it on screen and then use computer vision to determine whether or not there's a lot of occlusion happening because the links are overlapping each other or because the nodes are near each other. But there are still linting rules. There are still rules before data even applied to say, well, are you handling certain cases that happen with network data? And one of them that I like to think of, or that I've called orphanage, is a really useful one. So you have this network on the right here, or a network like this. And it's got a really great structure to it. You know, this is actually a useful network data visualization. And it's surrounded by this sort of satellites, this periphery of singletons, nodes that have no connection. So these would be people perhaps that have no friends on Facebook, or Twitter people who have no followers or something like that. Very sad singleton nodes. And when you leave them on screen like this, you might think, well, that's fine. People will be able to read this and they'll tell, look, they have no links. You can see that there's no line drawn between them to signify that there's a link. But what you're doing is you're providing visual clutter so that when somebody's trying to read this, they see this sort of periphery, like the satellite of the junk that circles the Earth. And you're damaging their ability to focus in on the structure of the network. So all orphanage is, as a rule, is that you have some kind of parameters in place that take singletons or other disconnected components and deal with them somehow. So in this case, pushing them all over to their own cluster and allowing you then to have two different modes for someone reading this where they can look at these related elements. They're related because they're singletons, and these other elements that are related because they're part of a great big component. And these are simple rules that you could be warned of while you're writing this, so that when inevitably this thing that was only meant to be a communication between you and someone else as a prototype gets out and it's not as effective as you thought it would be, you were warned of it in the beginning so you could handle it simply in the beginning. And presumably, if these rules became actual linting rules with an actual linter, were taken into account by the packages that we use that rely on these libraries. I wanted to spend a bit more time on color because oftentimes in talks and in writing, you hear people deal with color in data visualization, and the way that they deal with it is like this. They say, color is hard. And now moving on, and they go and talk about something else. Well, color is hard, sure. But there's actually recognizable rules that we can come up with for color that take advantage of advances that we've got in dealing with color. So for instance, if you are coding in D3, how many of you code in D3, like directly? And you're typing in D3 and you say scale linear, and you give it a domain that is an array of numbers, and you give it a range that is an array of colors, then it should come back and tell you, you shouldn't be doing that. That's bad. Color ramps are bad for people to understand things. You should bin them somehow, quartiles, quantiles, or whatever, and then use discrete color categories. That's just good practice. You should be warned when you're using more than 10 colors, because human beings aren't very good at distinguishing more than 10 categories of things. Now, maybe there are times when you need to use them. For instance, data visualization that's oriented towards search and exploration. But you should be warned about that. You should think about when you're using how many colors that you're using. You should take advantage of the libraries now that are in place that allow you to calculate just noticeably different color. So whatever colors that you're presenting are actually distinguishable. We should be warned when we use a set of colors and those colors are the same if colorblind users were looking at this. And we could easily be warned about that. That's not something that is someone's opinion, that's something that's testable. So these are things that could actually just pop up as you're coding. And you say, oh, I'm gonna make this into red and blue and green. And it says, well, you know, red and blue, these are gonna, or red and green, or whichever ones it is, depending on the kind of color blindness of your audience, you know that these aren't going to be distinguishable to a colorblind audience. More sort of simple rules, like you should think about what kind of background color you're using. We oftentimes deploy data visualization on a white background because that's the default. Why are you using a white background? Why are you using a black background? And just the mindfulness of thinking about that is going to improve your practice. And then finally, minimum color size. If you're using color, then the things that you provide color to should actually be a size that people can recognize that color. Because otherwise, and this is from a paper that was just published on Archive, and on the left there we see a whole, it's a bubble chart. I mean, throughout it, but especially on the left. We see things that have been given color, but they're so small that the color's bleeding into each other and creating these, again, following this Gestalt rule, creating these shapes that didn't exist in the data that do exist in the users or the readers who are exposed to this. So those kind of rules exist all throughout, and as you get closer to applying data to your chart, the rules can become a little bit more data-oriented. And in particular, and this is the last sort of set of rules I want you to think about, is that all data visualization should have annotation. Now that doesn't mean that your code can tell you, hey, you haven't annotated this well, or you haven't annotated this in the right places, the most interesting places, but at least it can tell you, hey, you know you haven't annotated anything here. And annotation, as we saw in the last talk, and as we're seeing more and more in data visualization, is extremely important for helping readers to understand the insights in the data. I work with Susie Liu. She just released this D3 annotation library that makes really sort of effective annotations much easier. And so we don't really have the excuse anymore to not annotate data visualization. And for an example of that, here's another one of these network charts. Like I said, I've been doing a lot of network charts lately. And this is a really interesting network. But what I've found is that when I say this is a really interesting network, and I'm there to explain to somebody why this is an interesting network, I give them the tools necessary to start to read that network. But when I just let this out into the world, and I say in my email, this is an interesting network, the response is typically this sort of blank stare. Whereas if I do some simple annotation to that network, then it not only provides points of insight within that data visualization, it also acts as a sort of moment of gentle training and introduction so that they can begin to look at similar network structures that you're not annotating. And so once again, these are all rules. And I've got a very primitive GitHub repo with a list of those rules and not much else, because I'm not big on writing linting systems. That's not my strength. My strength is making snarky tweets. But if we have these rules and we start to apply them, whether they're actually in your IDE or whether it's just a list of atomic rules that you can think of while you're building data visualization in Tableau, I think it's going to make us better in that creation phase. And I think that that's where we're seeing a real sort of weakness in how we're building data visualization. So thanks, everybody. Do I have time? Do I have any time? One question, the good one. All right, let's go to lunch. Oh, no, there's one. Sorry, guys.
I just had a question on if interactivity or mouse overs allow you to sidestep any of the rules that you've mentioned, because a lot of this was static, I think, maybe just for the talk and not for something on a website.
Well, we know that interactivity isn't well used in data visualization. So yes, you can have it so that interactivity allows you to get around problems with traditional data visualization creation problems when you're making prototypes. But interactivity is often aspirational on the part of the person creating the data visualization. So I think that you should still take them into account. And keep in mind that these are sort of, you could set this all to warnings, so it's all gentle, and you can still produce whatever chart you want. But maybe you'll be warned about it to make your process a little bit better. Interactivity isn't going to help with the fact that you've got a chart that's unlabeled, or it's using bad color, or it's using things that are overlapping each other. All right, thanks everybody.